Alright, welcome back to another episode of explaining past HSC questions. We are doing the 2015 HSC physics paper, question 24. Now, this one is relevant to Module 6, Inquiry Question 1, which is looking at how charged particles behave in electric fields and magnetic fields. So, in this particular diagram that we see here, we have a cathode ray oscilloscope. So oscilloscope is basically one of those machines where you can see little pulses, something like those. Okay. And this is the diagram we have. We have the cathode, where, as you can see, that's where the electrons are being emitted, and the anode, where the electrons are moving towards. If you actually have a look at this diagram, if we look at the notations, the cathode is actually the negative plate. The anode is the positive plate. So what you can see here is the electrons are being attracted towards the positive plate, and then you have some that just goes straight through like that as well. So our first question is explain why the representation of the path of our electron between these deflection plates, so this one and this one here, why is it inaccurate? Okay, so let's look at what we know first. Now, firstly, an electron is negative. And we know that negative charges will be attracted to something that's positive, and it will repel against something that's similar to it, which is also negative. If we have a look at the diagram we have here, the electron is moving towards the negative plate, which is not correct. So that's the first inaccuracy that we have in this diagram. Okay. So electron is a negative charge. It should be attracted to the positive plate. And not the negative plate as seen in the diagram. So that's the first thing, okay? It is 3 marks, so not only do you need to identify it, you need to elaborate why it's incorrect. So you could say, electron has gone to the wrong plate, but you need to justify why it's the wrong plate. And that's when you talk about the different type of charge and how they attract and all. So there's that. The next one is to do with the pathway. Now, from our studies, we've actually learned that the path of a charged particle in a electric field would follow something similar to a mass object in a gravitational field. So if I just picture a gravitational field and I launch a projectile along this gravitational field, it's going to have this parabolic shape of movement. If you have a look at this bit here, this is not parabolic, right? So it's not a parabola. It's not a parabolic pathway. What we should expect, the ideal scenario, if we also include where it's charged, firstly it needs to come down here to the positive plate, but it comes like a parabola. Okay? So that's the second part. So the second inaccuracy, the pathway of the electron should be parabolic. Rather than the sudden change in direction as seen in diagram. So you can write all that down. Now to aid you, what you could do is similar to what I've done here, actually label down the bits that are wrong and not correct. Just remember, an HSC marker is told that they do have to mark anything that's on the page. So if you do some little labels here and there on those diagrams and it validates one of the questions that you're answering, they can still give you marks for it as well. All right, next question. Calculate the force on an electron due to the electric field between the cathode and the anode. So the electric field we're looking at here is, if I just put it in color, is this bit. So from positive to negative, what is the electric field strength E here? If I just gather some data from my diagram, electric field strength is V over D. So got the 5,000 volts and D, the distance of separation, 2 centimeters. Okay, so if I look at my data sheet, in order to calculate the force, it's FQ capital E, and we know that E is given by the formula of V over D. So I can just also put that into my equation here instead. Just substitute it like that. Okay, so there we go. And if we have a look, we have the charge, which is minus 1.60 times 10 to the minus 19 times velocity or voltage, which is 5,000, and we have the distance 2 centimeters. So the answer I got for that is 4.005 times 10 to the power of negative 14 newtons. So it's a relatively weak force that is dragging it along. Now, and part of the marking criteria of this question, they don't really include the negative charge of the electron. So I assume what they were looking for was just the magnitude. But if you do get a negative, but if someone is confused why it's a negative value, we're just saying because it's a negative charge, so it's going in the opposite direction of the electric field. Okay, so this negative charge here moving opposite to electric field. That's what this negative value is showing here. Just to help you out, I'll show you the diagram again. The electric field is going from right to left on the page. The electron is going from left to right, so the opposite direction there. The next question we have is calculate the velocity of an electron as it reaches the anode. So let's just look at what the diagram says. So where the electrons are being released is from our cathode and going towards our anode here. Okay, so the way it actually works is electrons are actually being displaced from this piece of metal and it is being ejected out. So at this starting point here, it actually has an initial velocity of 0, and then it experiences some form of acceleration due to the electric field. So what we can actually use is some of our kinematics equations. Okay. So the kinematics equation we're going to use is v squared equals to u squared plus 2as. Why are we using this formula? Well, firstly, we know that we have a displacement that's 2 centimeters. We know that the initial velocity is, 0. We are trying to find the final velocity. That's what we're trying to find. We just need to know what acceleration is. Now, the force experienced by a charged particle in an electric field, you can equate that to Newton's second law. So mass times acceleration. And we already found what the force was. This time I'm just going to leave it as 4.005. The reason being is we're actually looking at the velocity, which is traveling in the same direction as the charge. So I can leave it at that, and it also helps when we do the square roots later on. But, if you want to continue in that manner with the negatives, that's fine too. So that's our value over. Okay, so that over the mass of an electron, which is 9.1 times 10 to the minus 31, that gives us our acceleration. Our acceleration would be equal to 4.39, and then all these other nice fancy long numbers. Meter per second squared, okay? Generally speaking, you can just round it off to 3 sig figs and then substitute it in, but, it's up to you. Now, if I rearrange the equation, so v square root u squared plus 2as, I know that u is going to be equal to 0. The acceleration, if I just write my value down, times my displacement, which is just 2 centimeters, so don't forget to change your units to match up with that. My velocity, rounded off, is approximately 4.20 times 10 to the power of 7 meters per second. So that's how fast my electron is traveling from that negative plate on the oscilloscope to the positive plate on the oscilloscope. So from here to here, that was the velocity we found. And that's how you do the question.